Welcome back. We are continuing our study of network virtualization, and in this lesson, we will talk about virtual networking in Mininet. I've divided this lesson into two parts. The first part of the lesson will cover the why and how of Mininet, in particular, what Mininet is useful for and how it works. In the next part of this lesson, we will look at various examples of using Mininet to create emulated network topologies, and I will also present various demonstrations of how to use Mininet. Mininet is essentially a virtual network environment that runs on a single PC. That is particularly useful for experimentation and learning in a course like this one, because you can complete all of the assignments and learn about SDN and OpenFlow simply using a virtual machine that's running on your PC at home. Mininet runs a real kernel, it can run real switch software, and it can run real application code on a single machine. It provides command line, graphical user interfaces, and Python interfaces to interact with it. And most importantly for this course, many OpenFlow features are already built into the environment. So this is particularly useful for developing, deploying, and sharing various things you might do in the Mininet programming environment. So why use Mininet? One, as we'll see, it's very fast. It's very easy to set up a network in Mininet. And in fact, we'll even do it in this lecture. It's also possible and actually very easy to create custom topologies. Third, hosts in the Mininet environment can actually run real programs. So anything that can run on Linux can actually run on a Mininet host as well. That's because Mininet uses something called OS virtualization, which basically means that it's running on Linux. So any program that can run on Linux can also run on a Mininet virtual host. Fourth, it supports programmable OpenFlow switches. What that means is that we can create a virtual network in Mininet and connect a real OpenFlow controller to real software OpenFlow switches that are running in the virtual network environment. And as we'll see, it's also very easy to use. It's clear to me now that a lot of you may not have a lot of programming experience, and therefore some of this may seem a little bit daunting. But I want to assure you that the amount of programming that's required to get familiar with SDN programming and controllers in Mininet is fairly straightforward and easy, even for someone who has relatively little prior programming experience. And in fact, in this lecture, we'll do a little bit of programming just to show you and demonstrate how easy it is to use Mininet. Finally, Mininet is open source. That means that not only can you examine how everything works, but also if you should want to add things to the Mininet environment, it is fairly easy to do so because everything is open source. So before we jump into the nuts and bolts of Mininet, let's consider various design alternatives. Well, one is to deploy everything on a real system. So you could deploy real servers, switches, and so forth. Of course, this is a huge pain to configure, right? Suppose that you want a network topology with a particular configuration or particular interconnections between the servers and switches. Well, you can set that up once. You can rack your machines, you can wire everything up to the switch, you can configure the switch and so forth. But suppose now you want to run a different experiment. Well, you've got to go back and reconfigure everything all over again. And in contrast, using Mininet makes it fairly easy to reconfigure these types of topologies because it's all in software. Another way that you could do this is to use networked virtual machines. So you could imagine running lots and lots of virtual machines, say on your laptop or on your desktop, and then network them together with a software switch that's running on your host. Now, the problem with that is that typically virtual machines are fairly heavyweight, so there's a limit to the number of virtual machines that you can run concurrently on a single host. So one of the advantages to Mininet that we'll see is that the OS-based virtualization that it uses is lightweight enough that it can support hundreds or potentially even thousands of hosts even on a single PC. Of course, the third alternative is just to use simulation, but the problem with that is that there's no clear path to hardware deployment. In particular, because everything is simulated and there's no real running software, and timing is not necessarily accurate, then it can be somewhat unclear how to transition an experiment that's run in simulation to a real working deployment. I just want to take one slide where we look at how Mininet works in a nutshell. And as we walk through certain examples, I'd like you to understand what's actually going on. So let's start over here on the left side of this figure. When we run Mininet, we'll often run something called MN, which is a launcher for the Mininet process. That process then controls the sub-processes, each of which represent a single host running in the network. So for example, let's suppose that I want to have a network with 2 hosts. The Mininet launcher would launch 2 bash processes, and then it would create a unique network namespace for each of those processes. So host 2, H2, and H3 would each have their own network namespace. And that's done with the Linux network namespaces mechanism, which is now native in the Linux kernel. At that point, each host or each process represents a host, and each of these processes has its own network namespace. And the next thing that happens is Mininet creates what are called virtual Ethernet pairs. And so the idea here is to create a tunnel between the virtual interface that's in the namespace of a particular subprocess. For example, here, the H2 namespace has a virtual interface, and we need to connect that to a real interface that's sitting in the root network namespace. The reason we want to do that is because eventually we're going to connect it to a switch. So each one of these hosts has a virtual Ethernet pair, and each pair is assigned to the namespace that corresponds to the virtual host that represents that particular node in the virtual network. Once those virtual Ethernet pairs are created and assigned to namespaces, we can then create an OpenFlow switch to connect those hosts. And finally, we can instantiate a controller that uses the OpenFlow protocol to control flow table entries in that switch. And those entries that sit in this switch here ultimately allow packets to travel between each of these hosts in the virtual network. And finally, this entire setup is contained within a single virtual machine. So all of this is basically running in a virtual machine on your PC. In summary, Mininet is a network emulator that runs in a virtual machine on a single node. It uses lightweight OS virtualization to achieve scale, and it's fast, easy to use, and makes it very easy to share various configurations, solutions, setups, etc. In the next part of the lesson, we will use Mininet to construct various examples of network topologies using both the MN wrapper and directly with the Python API.